CHEM 2211. This is our gas chromatography experiment where we convert an alcohol into a pair of alkyl halides, a chloride and a bromide. We're going to start out with 7.5 mils of concentrated sulfuric acid. We've got 10 grams of ice in a 100 ml beaker. We're going to mix those two together. This is an exothermic reaction. Of course, our sulfuric acid is going to be fuming. That's why we're underneath our snorkel here. So we'll go ahead and mix these two together very carefully. And you can see how quickly the ice melts in the presence of the acid. So we'll let that mix and we'll go ahead and weigh out the other components. So we added our sulfuric acid to our 10 grams of ice. That's a very exothermic reaction. It got very warm, but now everything is mixed together nicely. We've still got it under our snorkel just to be safe. We've weighed out the appropriate amounts of our ammonium chloride and our ammonium bromide. And we've listed our weights, our exact weights on our data sheet. So go ahead and take note of that. We're going to add our powder into our 125 Erlenmeyer flask. We're going to add a few boiling chips and then slowly add our acid solution. So that's our ammonium chloride. There we go. There's our ammonium bromide. Add our boiling chips. We've just got a few small ones here. And then we'll slowly pour in our sulfuric acid solution. We're going to make sure again that we're under the snorkel. Okay, we're all set. Mix this together. We're going to take it over to the hot plate and start heating it so it'll dissolve. Alright, so we've transferred our reaction mixture over to our hot plate. We've set it to around 74, 75 degrees Celsius. We've got our snorkel in place. We're going to heat this gently for a little while until all of our solid goes into solution, then we'll move on to the next step. So our solution is fully dissolved. Our ammonium bromide and chloride are dissolved into our acid and water solution. We're going to take this over and add it to our round bottom flask. I'm going to bring our snorkel over just to be safe. We're going to catch our boiling chips in our funnel. We don't want those to go in. We'll add our spin vane. We'll start it stirring just a little bit, just to agitate the solution. And then we're going to let it cool down to 30 degrees. I'll go ahead and move the thermometer into position. We'll wait for it to cool down to 30 degrees, and as long as we don't see any salt precipitation, we'll be ready to move on to the next step, which is adding our tert-butyl alcohol. We've reached our desired temperature in our reaction flask. It's stirring gently here. We're going to go ahead and lift the thermometer out, and I'm going to add in my tert-butyl alcohol. Here's our tert-butanol. We've got 1 ml. We'll go ahead and pipette it up. I'm going to place the tip of my pipette right near the bottom of our flask. I don't know if you can see that. Is it visible?
Yeah.
Okay. And then we're just going to slowly introduce our tert-butyl alcohol. We don't want to do this too quickly. If you can see the vapor evolution that's happening, the clouding of the glass. We don't want to do this too quickly, otherwise the reaction can get very violent. We're just going to do it slowly. Stir it just a little bit here. Try and keep the solution clear, although it is going hazy on us pretty quickly. Okay, and we've finished the addition of our tert-butyl alcohol. I'm going to go ahead and place a cold water condenser on top. And we're going to let it stir for about 5 minutes. Just like that. Make sure your condenser is seated properly. We'll go ahead and fill our condenser. Inlet and outlet, as always. We'll let this stir for 5 minutes and we'll come back and check on it. We've allowed our solution to stir for 5 minutes, then we let it stand for 5 minutes so that the layers will separate. We can see, if we get down to the level of the flask, a slight yellow layer on top, and that's our alkyl halide product layer. So what we're going to do now is we're going to take our reflux condenser off. I'm going to use a pipette to take away our lower aqueous layer as much as I can in the flask. And then once we get down to a couple of milliliters, I'll transfer it into a conical vial. So I'll set my pipette bulb. Out of your way here. I'll set my pipette bulb at the bottom. I'm going to go ahead and push air out of my pipette bulb. I'm going to set it down at the bottom and I'm going to start drawing up our aqueous layer. And as we reduce the amount of our aqueous layer, the alkyl halide layer will become a little bit more obvious. So I make sure that my pipette bulb is fully released before I draw it up through the layers. And then I'll discard my aqueous layer into the beaker here. I'll do the same thing again. layers are starting to separate out a little bit better each time we take out the aqueous. Okay, I've removed enough of the aqueous layer so we should be able to fit it into the conical vial. I'll go ahead and do that transfer, and then we'll come back once we're ready to do the final microscale extraction. I've transferred out the remaining solution from our round bottom flask, and when we get it into a small container like this 5 ml conical vial, it's a little bit easier to see the separation of the layers. Our alkyl halide layer, which is the top layer, is a pale yellow color. And then our aqueous layer, we can see the curve, almost a bubble-like appearance for the bottom layer of our aqueous solution. So I'm going to go ahead and keep removing aqueous and then discarding it into our catch flask here until we've just got our alkyl halide layer remaining. Using the same technique that we did before, pushing my pipette bulb down completely, going all the way down to the bottom, and just drawing up the aqueous layer. If something goes wrong, the beauty of this is that we can just pipette everything back into the flask and do the separation all over again, but we certainly hope that that won't happen. Pretty close to the end there. Just have to be very careful. I think I've gotten it all out. I'm going to swirl it one more time just to make absolutely sure so that anything that is aqueous will go to the bottom. I don't see any bubbles, so I think we've got just our pure alkyl halide layer. Okay, so our final step is going to be to neutralize any remaining sulfuric acid in the solution. We've got our alkyl halide layer here. We've separated out the aqueous. I have a little bit, about 0.06 grams of our sodium bicarbonate. We're going to use that as our neutralizer. I'm going to pour this into the vial. We're going to stir it up, and then we'll transfer it into a clean vial so we can weigh out our product. We'll agitate it to make sure it gets mixed in well, and then we're all set. So we're ready to isolate our final product. We can see our sodium bicarb layer in the bottom. That's neutralizing our sulfuric acid. We're going to draw off the alkyl halide layer. Now, just to be safe, I'm not going to take everything out of the vial that I placed into my pre-weighed clean 3 ml conical vial. So there is going to be a slight loss in our overall weight of product, but we expect that. We don't want to accidentally get any of our sodium bicarbonate drawn up into our layer and then we accidentally inject that into the GC. That can cause a lot of problems with our columns. So we'll get as much as we can while remaining safe. I'm going to use a new pipette, which I've got right here. And we're ready to go. can see I drew up a little bit of particulate with that. I don't know if we can see that on the camera.
Yeah,
so
you
I want to make sure that I push that back out, and I'll actually change over to another pipette just to be safe. I'm going to actually pick it up. And that's about the most that we can get out of there without accidentally taking. We can see that there's still some liquid remaining. So we know that the weight that we get off of this 3 mil conical vial isn't going to be perfect. We'll write that up accordingly in our lab report, but we've got enough that we can go ahead and analyze it using our GC. We'll cap this and we'll show you what the GC looks like. Okay, so this is a data sheet update on everything that we've done so far. So we have the weight of our final product in our vial. We have the weight of our vial alone. So that gives us a total of 0.65 grams of our final product mixture. We've recorded our sodium bicarb amounts. We've recorded the temperature at which we started the addition of our alcohol, our T-butanol. So everything is set and ready. Make note of all these values so that you can write them up on your lab report. Now we have our final product here. We're in our capped 3 mil vial. We're standing in front of our GC unit. We've got a GC 2014 from Shimadzu. We have our oven cavity here, which has our column. We're going to be injecting the sample into our TCD port. It will be pushed through the column to our detector. We'll take that data and post it up to ELC so you can see what ratios you created, or well, that we created during the course of this experiment. Good luck with your lab write-up.